we need to solve it to get the code. To get the code, we need to find the determinant. Okay. To find the determinant, we need to find the cofactor first. To find cofactor, based on this matrix, we need to close the first column and the first row. So it will just leave 3, 3, 5, 2, 3, 4, 2, 3, 5. Use this. And then to find the cofactors, we take the first number, which is C11 here, and then we close the first row, the first column, and the first row to get, and then we will see only 3, 4, 3, 5. So times the 3 with the 5, 4 with the 3. 5 times 3 minus 4 times 3. And then we will do this again, this process again with the C12, C13. And then we will get 0 for the first cofactor. We will find the C12 is cofactor for the next. We will get negative 6 and then negative 4 and then 6 for this and this. Yep. Good. For each matrix here, we need to put the symbol plus, minus, plus, minus, plus, minus from here to get the right cofactor. And then this C11, the number of these two we get from the first matrix from here, and we need to times it with 0, which is the first cofactor for the C11. Do the same thing for the C12, C13, and C14. And then we will get the determinant, which is negative 16. After that, after get the determinant, we need to arrange this cofactor in the form of matrix. This is the first row, this row, and then we will do the same thing for the next. To find the second row, we need to do the same thing to find the first row. Do the same thing until it fill up the 4 times 4 matrix. So,
as a matrix, we have to transpose it. So, the first row transpose into the first column. The second row transpose into the second column, and so on. So after that, after we get the transpose matrix, we have to inverse. So the formula for inverse matrix is 1 over determinant times with matrix transpose. So 1 over negative 16 times with this transpose matrix. And then times with this transpose, and then 1 over negative 16 times with 0, we will get 0. 1 over negative 16 times with negative 6, we will get 3 over 8, and same goes to this other number. Okay, and then we got matrix inverse, and then we have to times with matrix P. So matrix P yang tadi dalam soalan dah bagi, so kita darab je dengan matrix P. So the first row, cara nak darab dia, the first row times with the first column. Okay, untuk dapatkan ni negatif 59. So darab tu dapatlah negatif 59. Lepas tu the second row times with Oh, sekejap. Salah. Boleh cut kan? Okay, so the first row times with the first column. Lepas tu dapat negatif 59. Lepas tu, nak dapatkan yang ni, the first row times with the second column. Dapatlah negatif 21/2. Lepas tu, the first row times with the third column. Dapat negatif 69. And then the last one, the first column times with the fourth column. Dapatlah negatif 9/2. So, buat dia sama, same goes to these numbers, and then dapatlah macam ni. Lepas tu, according to the table, so kita dapat form satu je nombor, which is kosong. Dapatlah A je. Yang lain tak dapat. So the answer is no. The code cannot be broken.
Okay, hi everyone. So for my turn, I will be explaining on how to solve the K2 problem. The matrices that were given to me is these matrices: 4, 2, 5, 5, 2, 4, 4, 1, 3, 3, 9, 9, and 12, 6, 15, 15. And besides of the matrices, we have to put an identity matrix, because I will be doing an elementary row operation. As you all know, elementary row operation is an operation to find an inverse, but by using operations that involves only the rows. So the operations that we can do is the division of the rows, the addition, the multiplication, and also the when we exchange the places of the rows. For example, we put the row 1 and we change it into row 2 and row 2 into row 1. So I'll be continuing my. Okay, let's continue with our calculation. What we need to do is to match this matrix into the identity matrix. And the first thing I'm going to do is to match this number to the identity matrix. And what I'm going to do is to subtract this, the first row to the third row, which gives me number 1 on the first row. And the results are 1, negative 1, negative 4, negative 4, 2, 4, 4, 1, 3, 3, 9, 9, and 12, 6, 15, 15. And I want to get the 2 to become 0. So what I do is subtract R2 with 2R1, and it gives me 1, negative 1, negative 4, negative 4, 0, 6, 12, 9, 3, 3, 9, 9, 12, 6, 15, 15. And the third one is I want to get this 3 to become 0. So I'll be subtracting R3 with 3R1. And I'll be having 1, negative 1, negative 4, negative 4, 0, 6, 12, 9, 0, 6, 21, 21, and 12, 6, 15, 15. The 12 becomes 0, and I subtract R4 with 12 R1, which gives me 1, negative 1, negative 4, negative 4, 0, 6, 12, 9, 0, 6, 21, 21, and 0, 18, 63, 63. And I want to get this 18 to become 0 also. So what I do is R4 is subtracted with 3R3, which gives me 1, negative 1, negative 4, negative 4, 0, 6, 12, 9, 0, 6, 21, 21, and 0, 0, 0, 0. And if you can see that there's a 4 0 in the row 4, so this means that there's no solution, because one of the rules to get an inverse is not having these kind of numbers in any rows. So if we have these numbers in any rows, that means that the matrix cannot be inverse. So there is no solution. Hence, this matrix is incorrect and the code cannot be broken. Thank you.
Okay, so now we will proceed to the K3 matrices form. So this is the 4 by 4 matrices form that is given in the question. Okay, so we need to find the inverse of the matrices form. So firstly, we want to find the inverse using the adjoint method. We need to find the determinant first. So the first step we want to find the determinant is by deleting any rows or any columns that we want. So for us, we'll delete the first row. Okay, firstly, we need to find the minus of each row by deleting the others column. So the first step is we close the first row and column 1. So the minus is 1, 5, 2, 2, 5, 3, and 4, 1, 1. So for the row 2, we close, and for the column 2, the minus is 5, 5, 2, 4, 5, 3, and 1, 1, 1. And proceed the next step to close the first row and column 3, which is the minus is 5, 1, 2, 4, 2, 3, and 1, 4, 1. Okay, so for the when we close the row 1 and column 4, we'll get the minus, which is 5, 1, 5, 4, 2, 5, and 1, 4, 1. So seterusnya, when we kita dapat the minus for each rows, we need to find the cofactors of the rows. So the start, so cara dia hampir sama, which is we need to close the rows and columns. So firstly, we close the row 1 and column 1 of this minus, and the remaining numbers is 5, 3, and 1, 1. So we will multiply it, we will cross multiply, and we minus it by itself. So 5 times 1 and 3 times 1. So we minus it and get 2. So we proceed it for each column. Which the second column we get the remaining number is 2, 3, and 4, 1, and seterusnya macam itulah. So we need to repeat the step for each minus to get the cofactors. So bila kita dah total up semua, kita akan dapat jumlah cofactors dia, which is for the minus 1, the cofactors is 16, and for the minus 2, the cofactors is 3, and for minus 3, the cofactor is negative 73, and for the minus 4, the cofactors is negative 19. So bila kita dah dapat setiap minus ni as setiap cofactors, kita perlu we need to multiply it by each number of the first row to get the final determinant. So we'll multiply the first cofactor, which is 16, by the first number of the first row, which is 4, and 3 with 95. This is the reminders that we need to consider the symbol of each row, which is for the first row the symbol is plus, and then minus, plus, minus. So when we want to calculate the determinant, we need to consider the symbol. So we proceed it 16 times by positive 4, 3 times it by negative 23. We multiply it by positive 4, and negative 19 we multiply it by negative 5. So when we calculate it, the final determinant is negative 12. So kalau kita nak confirmkan that our determinant is correct, we need to repeat all the steps for each row. So now we will proceed to the other steps. Okay, now as I mentioned before, we need to find each cofactors for each minus and arrange it in a new adjoint matrix. So we need to calculate the cofactors by using the same method as shown before, that we need to close any rows or columns and multiply and minus it by itself. So this is how we arrange the cofactors, which is by cofactors for row 1 and column 1, row 1 and column 2, row 1 and column 3, row 1 and column 4, and this is the next cofactors. So this is the value of cofactors that we get when we calculated it. So this is for the cofactors of row 1 and column 1. This is 16, 3, negative 23, negative 19, negative 4, 3, negative 7, negative 15, 12, 0, negative 12, 0, 4, negative 3, negative 5, and negative 1. So this is the new adjoint matrix that we had calculated. So when we already get the adjoint matrix, we need to transpose it to form adjoint transpose matrix. So the transpose meaning is we change the rows into columns. So the method is shown here that we change the row 1 into columns 1, which is 16, 3, negative 23, negative 19 in row 1 become the column 1, and also row 2 into column 2, row 3 into column 3, and row 4 into column 4. So this is the adjoint transpose matrix that we get, and that will be used to find the inverse later on.
Moving on to the next step, where we have already found the transpose of these adjoint matrices, which is we have already converted rows into columns, and we have already multiplied with the appropriate symbols, which is plus, minus, minus, plus, and so on. Now, for us to find the inverse of the matrices, we have to use this formula, which is 1 over determinant, we multiply with the adjoint transpose, which is this one, and the determinant that we have already calculated before, which is negative 12. Now we just substitute the formula, which is 1 over negative 12, we multiply with the transpose of the adjoint that we have already calculated before. Then we multiply each cofactors in this matrices with the determinant, which is 1 over negative 12. And next we will find the inverse of the matrices, which is this one. Now, for us to break the code according to the questions given to us, the formula is matrices P, which is already given in the question, which is this matrices. We have to multiply with the inverse of matrices A, which is this one. So we just substitute the formula, which is matrices P, we multiply with the inverse, and then we will get a new code matrices, which is this one. And we have to break the code by changing all of these numbers into the alphabet that has already given in the questions. Now we will need to break the code, which is algebra calculus. So this shows that K3 is the correct matrices, and we managed to break the codes given by his brother. Thank you.